Hi there, and welcome to the exciting first part of the assessment 2.4 here. So this is the formative assessment. So the rocket's launched vertically upward at our initial velocity, right? So this will be our initial velocity for 1, 2, and 3, right? You just can't forget that, right? Okay, so here's what it's going to do. It's going to go up. Whoa, it's going to go down. Okay, actually here, it's going to go up. Oh, look how straight that is, and then it's going to go down. It's amazing how straight I can draw. Either that or I'm holding the shift key down, right? Apparently it goes up 40 meters, right? But the first thing is, what time will it take to reach the top? What's the greatest height it reaches? What total time will it be in the air? Okay, so what I'm going to do is I'm going to go from the ground to the top. Okay, you always have to have an opinion about what you're SUVOTing. So I'm going to go from here to here, and then we'll figure out how to figure out the total time here in a sec. Okay, so ground to the top, if I do this, okay, if I do ground to top, my displacement is one of the things I want to find. My initial velocity is 28 meters per second, right? My final velocity at the top is 0, right? Okay, so my final is 0, my initial velocity is 28, right, meters per second. And then my acceleration the whole time is negative 9.81 meters per second squared, right? So to figure out the time to reach the top, I would choose a formula that has no s in it, right? So that would be v equals u plus at, right? So the final velocity is 0 at the top, that's 28, plus negative 9.81 times t, right? So the free fall acceleration is always negative 9.81. Okay, so now we're all set. If I do this, 28, basically it's just 28 divided by 9.81. I get 2.8542. Seconds, right? Now, let's just skip ahead. The total time it's in the air is just twice that, right? It takes 2.8542 seconds up, right? And the same amount of time down, right? So the total time, we can just go 2.8542, right? Or the answer on my calculator, times 2, right? So times 2. And if I do that, I get 5.71 roughly, right? But you only get that if you double the rounded value, or the unrounded value. Sorry. Okay, so you got to like carry a bunch of extra sig figs, right? If you cut that thing off there, then doubling is 5.70, right? All right, and then we want to figure out the height that it reaches, right? Now to do that in a sort of morally pure way, I won't use the time. I'll use no t, right? So I'm going to use v squared is u squared plus 2as. Okay, so 0 squared is 28 squared plus 2 times negative 9.81 times s, which we don't know, right? Okay, so let's see. If we solve this thing, we're going to end up with 0 squared minus 28 squared divided by 2 times negative 9.81. And then that equals s. Okay, so if I do that, divided by 2 divided by 1, I get 39.959. 959. And then, the hardest part here is how do you round that to 2 sig figs, or 3 sig figs, right? This is bigger than 5, right? So we'd have to say 40.0, okay? So the trick to this first one really is to realize that you have to go from the ground to the top and that the velocity at the top is 0, okay? Because if it's not 0, it's not at the top, is it?